Hello everyone, and welcome back to the Fluctus Channel. The Lockheed C-130 Hercules has been one of the most important cargo aircraft in U.S. military service for more than 7 decades. First introduced in the 1950s, the 4-engine turboprop was built to carry troops, vehicles, pallets, and ammunition into places many larger aircraft could not reach. Its high wing, rear loading ramp, rugged landing gear, and short takeoff and landing capability allowed it to operate from rough forward strips, making it a true battlefield workhorse. Over time, the Hercules evolved into far more than a transport. Variants of the C-130 have served as aerial tankers, gunships, weather reconnaissance aircraft,
that's a good sign. Hey, started doing commercial flights over there.
rescue platforms, and special operations transports. More than 2,500 have been built, and the aircraft has served with the United States and dozens of allied nations, making it one of the most widely used military airlifters ever produced. That long service life, however, also means many Hercules airframes eventually wear out. After years of heavy cargo loads, repeated pressurization cycles, hard landings, desert dust, corrosion, and constant maintenance, some aircraft simply become too expensive or impractical to keep flying. And when that moment comes, the ending can be surprisingly violent. In one remarkable scene from Iraq, a retired C-130 is not preserved with ceremony or quietly parked out of sight. Instead, it is actively dismantled by heavy demolition equipment. Massive machines tear into the fuselage, crushing and ripping apart the giant airlifter section by section. The body folds in on itself. The aircraft's skin splits open. Panels buckle, beams twist, and the once proud transport is reduced to torn aluminum and scrap. For an aircraft that may once have cost tens of millions of dollars and carried troops into danger, it is a shocking image. But this kind of destruction happens only after the aircraft has already given up everything useful. Reusable components are removed, sensitive equipment is taken out, fluids are drained, and valuable systems are harvested. What remains is not an operational aircraft anymore, but an empty shell that has reached the end of its usefulness. For many other C-130s, the final chapter begins with one last landing in Arizona. At Davis-Monthan Air Force Base sits the 309th Aerospace Maintenance and Regeneration Group, better known as AMARG, the famous aircraft boneyard. For some crews, flying a Hercules into this desert facility means making the aircraft's last flight and final landing. The runway there becomes a point of no return, where aircraft stop being active military tools and begin a completely different role as stored assets, parts, donors, or demolition candidates. AMARG is enormous. Spread across about 2,600 acres, it has stored more than 3,000 aircraft at a time. And at some points, the total inventory has approached roughly 4,000. From above, the scale is staggering. Bombers, fighters, tankers, transports, helicopters, and special mission aircraft sit in tightly organized rows stretching deep into the desert. The location is ideal because Arizona's dry climate slows corrosion and allows aircraft to remain intact far longer than they would in humid environments. That is why the boneyard is not simply a dumping ground. It is a massive preservation and logistics center for the U.S. military. Some aircraft parked there are held in recoverable condition and may someday fly again. Others are kept mainly to provide spare parts for the active fleet. A retired C-130 may never leave the ground again. But its engines, propellers, avionics, landing gear assemblies, control surfaces, and countless smaller components can continue supporting aircraft still in service around the world. In that sense, the boneyard is really a giant warehouse, where old machines continue serving the military long after retirement. One of the most recognizable parts of that process is the protective coating applied to stored aircraft. Crews spray many of them with a white vinyl sealant, often known as Spraylat. It covers windows and surfaces, shielding the aircraft from punishing sun, dust, and temperature swings. The result is the ghostly sight of rows of white painted planes that look almost frozen in time. Some will be regenerated. Some will be harvested for parts. And some, once the military decides they have no remaining value, will be dismantled and destroyed. That is the key point. The United States does not blow up or tear apart million-dollar aircraft for spectacle. It does so only after squeezing every possible use from them. The same logic extends to old warships. Naval vessels also serve for decades, but age, maintenance costs, and changing technology eventually force them out of the fleet. When that happens, a ship is decommissioned. Its active service ends, its crew departs, and the vessel enters a final phase. Some become museums. Some are transferred to Allied navies. Some are sent to reserve fleets or ship graveyards, including holding areas around Pearl Harbor where retired ships can be seen awaiting disposal or reassignment. Others get a much more explosive last mission. That mission is SINKEX, short for sinking exercise, often conducted during RIMPAC, the Rim of the Pacific exercise, the world's largest international maritime war game. Instead of letting a decommissioned warship simply rust away, the U.S. Navy and its partners can use it as a full-sized live-fire target. Before that happens, the ship is carefully stripped of fuels, pollutants, and hazardous materials in order to meet environmental and safety rules. Only then is it towed to sea and assigned one final purpose: helping train the force that will replace it. Submarines are a major part of this process. During SINKEX, footage shows how weapons handling aboard a submarine is highly controlled and methodical. Torpedoes and anti-ship missiles must be moved, checked, aligned, and prepared according to strict procedures before launch. A submarine, such as USS Olympia, can then fire from concealment, showing exactly why undersea warfare remains one of the deadliest threats at sea. But the event rarely stops with one platform. SINKEX becomes most dramatic when air and naval forces attack together. Aircraft strike from above with guided weapons. Surface combatants launch missiles from range. Submarines attack from below the surface. In some exercises, carrier strike assets and multiple Allied units are integrated into the sequence. The decommissioned ship becomes the center of a carefully choreographed assault that tests coordination, timing, communications, targeting, and battle damage effects on a real hull rather than a mock target. Every hit generates data. Commanders learn how weapons perform. Analysts study how ships flood, break, burn, and finally sink. Engineers and planners get a clearer picture of what modern anti-ship firepower can actually do against a large vessel. And after that, the cycle continues. Other retired ships depart active service and head toward graveyards, reserve fleets, or dismantling facilities, while a select few are chosen for one last blast of relevance in live-fire training. So whether it is a giant C-130 torn apart by heavy equipment after years of service, or an aging warship sent to sea to be smashed by torpedoes, missiles, and bombs, the reason is the same. The US military tries to extract one final layer of value from its old machines, even when that last use ends in scrap, fire, and heavy explosives. And while old cargo aircraft and decommissioned warships may meet their end in desert scrapyards or explosive SINKEX events at sea, end-of-life nuclear-powered submarines go through an even more controlled and fascinating final chapter. When a submarine like USS Olympia reaches the end of its operational life, the process begins not with destruction, but with a final arrival. At Bremerton, Washington, these long-serving undersea warships return to port one last time for decommissioning, closing out decades of silent patrols, training missions, and strategic service. Unlike aircraft or surface ships, submarines are far more difficult to retire because of their dense internal systems, thick pressure hulls, and, in many cases, nuclear propulsion. That means they cannot simply be left to rust, scrapped casually, or used as live-fire targets. At Puget Sound Naval Shipyard, the disposal and recycling process becomes an industrial operation of extraordinary precision. Once the submarine is formally decommissioned, workers begin stripping out systems, equipment, wiring, piping, and components that can no longer remain inside the vessel. The boat is opened up section by section, and what once looked like a seamless black war machine becomes a maze of exposed compartments, cut metal, and heavy structural frames. Specialized crews then begin cutting into the hull itself, using controlled methods to break the submarine into manageable sections. This is where the process becomes especially dramatic. Massive portions of the submarine are removed piece by piece, with entire hull sections separated and lifted away. These are not small fragments, but giant cylindrical structures made from some of the strongest steel in the fleet. Once detached, enormous cranes move the dismantled sections across the shipyard with remarkable care, carrying what remains of a once secretive warship like giant pieces of a mechanical skeleton. It is demolition, but at the level of heavy engineering rather than brute force. And yet, just like the retired aircraft in the boneyard or the decommissioned ships used in SINKEX, the goal is not simply to destroy, it is to extract value. So even after active service ends, these vessels can still teach, support, and prepare the next generation. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.